Right now, somewhere on this planet, the ground is hot enough to cook an egg, not in an oven. Out in the open, under a sky with no clouds and no mercy. The sand is past 60 degrees Celsius. The air shimmers until the horizon melts into a silver lie. And in that furnace, life is not just hanging on. It is thriving. While you reach for a cold drink and an air conditioner, an entire cast of animals is out there solving a problem that should kill them, using tricks so strange and so elegant that they feel almost like cheating physics. This is the story of how animals survive extreme heat. And by the end, you will understand the single invisible line that even the toughest survivor on Earth cannot cross. Let's start where the heat is oldest, the Sahara, nearly the size of the entire United States, and in the deep summer, the surface can climb toward 80 degrees Celsius. The animal everyone pictures here is the camel, and almost everything you think you know about it is wrong. That hump is not a tank of water. It is a tank of fat, stored on the back instead of wrapped around the body, because a layer of fat over the whole animal would trap heat like a winter coat in a heat wave. Keeping the insulation in one neat pile lets the rest of the body shed warmth, but the camel's real magic is invisible. Most mammals, including you, hold their body temperature almost perfectly steady. Spend energy and water to stay cool, no matter the cost. The camel refuses. It lets its body temperature rise through the day, from around 34 degrees in the cool morning all the way to 41 by afternoon, 7 degrees of drift. By simply allowing itself to heat up and storing that heat like a battery, the camel avoids sweating for hours, and that saved water can be the difference between life and death. At night, the stored heat radiates back out into the cold desert air and the camel resets, ready to do it all again. And when a camel finally does drink, it drinks like nothing else alive, over 100 liters in about 10 minutes. Its red blood cells are shaped to swell without bursting, so it can flood its body with water that would kill another animal through shock. Long lashes shield the eyes, slit nostrils close against blowing sand, splayed, padded feet spread its weight across the dunes. The camel is not surviving the desert. It was built piece by piece by the desert itself. Now shrink the scale. Down near the sand, where the heat is even more brutal, lives a creature that looks like it was drawn for a fairy tale. The fennec fox, barely larger than a kitten with ears that seem absurdly, comically huge. But those ears are not for show, and they are not really for hearing, though they hear beautifully. They are radiators. Each ear is a thin sail of skin laced with blood vessels close to the surface. As warm blood flows through, heat bleeds out into the air, cooling the animal from the inside without spending a single drop of water. Relative to its body, the fennec has the largest ears of any fox on Earth. It spends the blistering day underground, in burrows that can be 10 or more degrees cooler than the surface, and emerges only when the sun lets go of the sky. That trick, oversized ears as cooling fins, scales all the way up, travels south into the savanna, and you meet the master of it, the African elephant, the largest land animal alive and one with a serious heat problem. The bigger an animal is, the less surface it has compared to its volume, which means big bodies struggle to dump heat. So the elephant grew the largest ears on the planet and turned them into living air conditioning. Spread through each ear is a web of blood vessels you can sometimes see from across the savanna. When the elephant flaps those ears, it pushes air across that warm skin, and blood returning to the body can be as much as 10 degrees cooler than when it left. On a hot day, an elephant in the shade, ears swinging like enormous fans, is quietly running one of the most powerful cooling systems in the animal kingdom. Now cross the planet to the red sands of the Australian outback, where the midday sun turns the ground to a griddle, and meet an animal that cools itself with something it always has on hand, its own spit. When a red kangaroo overheats, it licks a thin film of saliva onto the underside of its forearms, exactly where the skin is thinnest and the blood runs closest to the surface. As that saliva evaporates in the dry air, it draws heat out of the blood flowing just beneath, like dabbing your wrist with water on a hot day, except the kangaroo has built the trick into its body. A network of fine blood vessels sits right under that licked skin. so the cooled blood flows straight back to the core and lowers the animal's whole temperature. It is sweating on purpose in just one place, and only when it needs to. And in the same scorched country lives perhaps the most extreme water saver of all. In the deserts of North America, the kangaroo rat may go its entire life without ever taking a single drink, not from a stream, not from a puddle, not even from dew. It manufactures its own water, chemically, from the dry seeds it eats, squeezing moisture out of food through its own metabolism. Then it guards every drop with a body tuned for thrift. Its kidneys are so powerful that its urine comes out almost as a paste, and it breathes through cooled nasal passages that recapture the moisture in its own breath before it can escape. It spends the day plugged into a burrow it seals behind itself, raising the humidity around its body so it loses even less. A mammal that beat the desert by refusing to drink at all. Heat is one half of the desert's cruelty, thirst is the other. And nowhere is the water problem solved more strangely than along the coast of the Namib, one of the oldest deserts on Earth, where it almost never rains, but a thick fog rolls in from the cold Atlantic at dawn. There, a small black beetle climbs to the crest of a dune, turns to face the incoming fog, and does a headstand. As the mist drifts over its body, tiny droplets condense on its hardened wing cases and trickle down channels in its shell, straight into its waiting mouth. It is drinking the air. With this one behavior, a fog-basking beetle can take in more than a tenth of its own body weight in water from a single morning. No rain required, just gravity, chemistry, and the patience to stand on your head and wait. The fog beetle is not alone in its genius. In the red heart of the Australian outback lives a lizard that looks like a walking pincushion covered in spikes. The thorny devil, and it has solved thirst in a way that sounds impossible. It drinks through its skin. Microscopic grooves run between every spine, forming a hidden network of channels across its entire body. When the lizard stands on damp sand, or when dew settles on it overnight, water is pulled up through those grooves by capillary action against gravity, all the way to the corners of its mouth. The thorny devil never needs to find a puddle. It simply touches moisture anywhere on its body, and its own skin pipes the water to where it can swallow it. Some animals don't engineer the water, they become living delivery trucks for it. Out across the dry plains live the sand grouse, plump desert birds with a parenting problem. Their chicks hatch far from any water and cannot fly to drink, so the father solves it with his own body. He flies, sometimes 30 kilometers to a water hole, wades in, and rocks his chest back and forth in the water. His belly feathers are specially structured to hold liquid like a sponge, soaking up far more than ordinary feathers ever could. Then, waterlogged and heavy, he flies all the way home, and his thirsty chicks crowd beneath him to drink straight from his soaked feathers. A bird that turned itself into a flying canteen. Back in the savanna, the heat is rising and the body is overheating, but there is a problem you may not have considered. Birds cannot sweat. They have no sweat glands at all. So how does an ostrich, the largest bird on Earth, standing exposed on a baking plane, keep from cooking? It cheats in two ways. First, like the camel, it lets its body temperature climb several degrees before it starts spending water to cool down. And second, it pants in a way called gular fluttering, vibrating the thin skin of its throat dozens of times a second. Each flutter evaporates a little moisture and carries off heat, like an internal fan. On the hottest afternoons, it also lifts its wings away from its body, exposing bare patches of skin to any breath of breeze. A 2-meter bird cooling itself with a throat and a pair of half-open wings. Now look down at the smaller residents of the same plains and you find one of nature's most charming inventions. The Cape ground squirrel of southern Africa carries its own umbrella everywhere it goes. When it forages out in the full sun, it arches its big bushy tail up and over its back, holding it like a parasol between its body and the sky. That patch of shade it carries can drop the temperature on its back by several degrees, enough to let it keep feeding through the hours when other animals are forced to hide. It is shade you can take with you, grown right out of your own body. Even the giants of the desert plains have an answer written into the color of their coats. The addax and the oryx, pale desert antelopes, wear almost white fur that reflects the harsh sunlight instead of soaking it up. Their bodies are so efficient that they can go for long stretches drinking almost nothing at all, pulling moisture from the dry plants they eat and the cool air they breathe at night. They time their movement, grazing in the gentler hours and standing still through the worst of the heat, turning their bodies to present the smallest possible surface to the midday sun. Survival for them is partly a matter of geometry, and the oryx hides one more secret inside its own skull. Like the camel, it lets its core temperature climb to levels that would be dangerous for most mammals, sometimes past 45 degrees. The catch is that the brain is far too delicate to survive that kind of heat. So the oryx built a cooler just for its head. The blood heading up to the brain passes through a fine mesh of vessels sitting right next to the cooled blood returning from the nose and the breathing passages. Heat jumps from one stream to the other, and the blood reaching the brain arrives several degrees cooler than the rest of the body. The animal can let its body run hot to save water, while keeping the one organ that truly cannot overheat safely chilled, a built-in radiator wrapped around the most important thing it owns. And the jackrabbit, racing across the Sonoran Desert of North America, carries the same fennec trick on a different body. Its ears are enormous, thin, and threaded with blood vessels. As it rests in the shade, those ears glow faintly red, radiating the day's heat straight out into the air without losing a drop of water to sweat. Big ears, again and again, evolution's favorite radiator, reinvented on continents that never touched. But some heat is simply too much to fight head-on, so a few animals do something that feels like science fiction. They opt out of time itself. When the dry season turns the land to dust, certain desert snails seal the opening of their shells with a chalky lid, a dried membrane that locks the moisture inside, and they cluster on the stems of dead plants and stop. Their heartbeat slows to almost nothing. Some can wait this way, sealed and still, for months, even years, until rain finally returns. This deep summer sleep is called aestivation, and it is the mirror image of hibernation. Where the bear sleeps through the cold, these animals sleep through the heat. Underground, a frog does the same. The water-holding frog of the Australian desert burrows down, fills its body and bladder with water like a living balloon, and then secretes a cocoon of shed skin and mucus around itself, sealing in every drop. There it waits, buried, sometimes for years, a green pocket of life hidden beneath cracked, lifeless clay. When heavy rain finally soaks through the soil, the frog wakes, breaks out of its cocoon, climbs to the surface, and the dead desert erupts into a chorus of calling frogs overnight, as if the rain had conjured them out of nothing. And almost every survivor shares one last, simple piece of wisdom that ties all of this together. They cheat the clock of the day itself. Walk through any true desert at high noon, and it can look completely dead, not a creature stirring, the heat pressing down like a weight. But that emptiness is a trick of timing. Most of the life is simply waiting underground or in deep shade, riding out the worst of it. Then, as the sun finally slides toward the horizon and the killing heat bleeds out of the sand, the desert wakes up. Foxes slip out of burrows, lizards emerge to hunt, rodents scatter across the cooling dunes. By becoming creatures of dawn, dusk, and night, they sidestep the deadliest hours entirely and turn the desert from a furnace into something they can actually live in. Sometimes the smartest adaptation is not a special organ at all. It is knowing exactly when to show up. So everywhere you look in the world's hottest places, life has found a door. Store the heat and dump it at night. Grow radiators for ears, drink the fog, drink through your skin, fly water home in your feathers, carry your own shade, reflect the sun, or simply stop the clock and wait the heat out. Every one of these is a different answer to the same brutal question. How do you stay alive when the sky is trying to kill you? But here's the part that should make us all pause. Every one of these survival tricks has a ceiling. There is a single number that no amount of clever evolution can beat, and it is called the wet bulb temperature. It measures heat and humidity together because the real danger is not just how hot it is, but whether your body can still shed heat by evaporation. In dry air, sweat, and panting work, water evaporates and carries heat away. But when humidity climbs, evaporation stops working. And when the wet bulb temperature reaches about 35 degrees Celsius, the body of any mammal, no matter how adapted, can no longer cool itself at all. Heat just builds and builds with nowhere to go. For most of human history, almost no place on Earth had ever crossed that line. It was a theoretical limit, a number in a textbook. But as the planet warms, brief, deadly wet bulb spikes have already been recorded in parts of the Persian Gulf and South Asia, places where for a few hours the air itself becomes lethal to step into. The camel's drifting temperature, the fennec's radiator ears, the elephant's fanning, the beetle's fog, the frog's cocoon, every brilliant trick in this video runs out of road at that wall. Past the wet bulb limit, there are no survivors, only shelter. And that is the quiet warning hidden inside all this wonder. These animals are not just amazing, they are the front line. They live closest to the edge of what life can endure, which means they will feel the heat rising before we do. The fennec, the oryx, the sleeping frog beneath the clay, they are the early warning system for a planet running a fever. The desert has spent millions of years teaching its creatures how to survive the impossible. The real question now is whether we are paying attention. So here is what we want to know from you. Of all these survivors, which adaptation amazed you the most? The camel that stores heat like a battery, the lizard that drinks through its feet, or the frog that can sleep for years waiting for rain? Tell us in the comments. And if this changed the way you see the hottest places on Earth, stay with us, because the natural world is full of impossible things that turn out to be true.